We are covering pump curves, system curves, net positive suction head, and cavitation for the FE civil exam. Let's start with the pump curve, which is provided by the manufacturer. It shows the head a pump can deliver versus the flow rate it produces, and it's always a downward sloping line. As the flow rate, Q, increases, the pump head, H, that it can provide decreases. Next, we have the system curve, which represents the head your specific piping system requires to move the fluid. This curve always slopes upward because it's the sum of the static head and friction losses. Static head is the fixed vertical distance the fluid needs to be lifted, while friction losses increase with the square of the flow rate. You can find the Darcy-Weisbach equation for friction losses in the Fluid Mechanics section of the NCEES FE Reference Handbook. The most common exam question involves finding the operating point, which is simply the intersection of the pump curve and the system curve. This point tells you the actual head and flow rate the pump will achieve in that specific system. On the exam, you might be given equations for both curves and asked to set them equal to each other to solve for the flow rate. Once you have the operating point, you'll likely calculate the required pump power. The fluid power formula, P equals gamma times Q times H, is in the handbook. A major exam trap is confusing fluid power with the electrical power required to run the pump, also called brake horsepower. To find the brake horsepower, you must divide the fluid power by the pump's efficiency, eta. Always be careful with units, especially converting to horsepower in the USCS system. Now for a critical concept, net positive suction head, or NPSH. This is all about preventing cavitation. Cavitation is the formation and violent collapse of vapor bubbles inside the pump, which sounds like pumping gravel and can severely damage the impeller. To prevent this, the net positive suction head available, or NPSHA, must be greater than the net positive suction head required, or NPSHR. NPSHR is a property of the pump that you find on the manufacturer's curve. NPSHA is a property of your system's suction side that you must calculate. It is the absolute pressure at the pump's suction inlet minus the fluid's vapor pressure. An exam trick question might involve a system at a high altitude or with a high temperature fluid, both of which lower the NPSHA and increase the risk of cavitation. Here's a mnemonic to remember the rule. Available must be above required. Think AAR. NPSH available must be above NPSH required to avoid cavitation. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.